Hello friends, welcome to my YouTube channel Chemistry the Central Science. Now today we gonna talk about the aldehydes. So let's begin. Now basically what is aldehyde? Aldehyde is an organic compound containing the group CHO. Here is a general structure of aldehyde. Here is a R group and here is a CHO group. R group is any alkyl or aryl group. Now let's see some examples of aldehyde. Here is a formaldehyde. Here is a acetaldehyde and here is a propanaldehyde. This is also known as respectively methanal, ethanal and propanal. Okay, here is some simple preparation methods of aldehyde. See, you can take screenshot or simply the video, pause the video and make your own notes. It will be effective. Let's see one by one. First method is from acyl chloride. Acyl chloride also known as acid chloride. When acyl chloride is hydrogenated with palladium over barium sulfate, it gives benzaldehyde. This reaction is known as Rosenmund reduction. Okay, here is a reaction of Rosenmund reduction. See, benzyl chloride is hydrogenated over palladium and barium sulfate gives us benzaldehyde. Okay, here is a second method from nitriles and esters. Nitriles are reduced with stannous chloride gives imine in presence of hydrochloric acid, which on hydrolysis gives aldehyde, and this reaction is called as Stephan reaction. Here is the reaction. Nitrile group is reduced with stannous chloride and HCl. It gives imine and imine goes hydrolysis form aldehyde. Okay. Another is nitriles are selectively reduced by diisobutyl aluminum hydride means diabyl H. It will form imine followed by hydrolysis to aldehyde. Here is the reaction. You can pause or take a screenshot. Okay. Similarly, esters are also reduced to aldehyde with diabyl H. Here is the reaction. So we can see here is a long alkyl chain attached with ester group with diabyl H and H2O. It is reduced and forms as aldehyde, and here is as connected alkyl group. The third method is from hydrocarbon. Here we can prepare aromatic aldehydes like benzaldehyde and its derivative from aromatic hydrocarbons. There are so many methods. First is by oxidation of methylbenzene. Strong oxidizing agent oxidize toluene and its derivative to benzoic acid. However, it is possible to stop that oxidation at the aldehyde stage with suitable reagent that convert the methyl group to an intermediate that is difficult to oxidize further. Here is the following methods. First is use of chromyl chloride. Chromyl chloride oxidizes methyl group to a chromium complex, which on hydrolysis gives corresponding benzaldehyde. So here is the reaction. Toluene is reacted with chromyl chloride, gives us chromium complex. On hydrolysis, it gives benzaldehyde. This reaction is called as Etard reaction. Okay, here is another method, use of chromic oxide. Toluene or substituted toluene is converted to benzylidene diacetate on treating with chromic oxide in acetic anhydride. The benzylidene diacetate can be hydrolyzed to corresponding benzaldehyde with aqueous acid. Here is the reaction. Okay, this is a commercial method of synthesis of benzaldehyde by side chain chlorination followed by hydrolysis. Side chain chlorination of toluene gives benzyl chloride, which on hydrolysis gives benzaldehyde. This is a commercial method of manufacture of benzaldehyde. Let's see the reaction. This is toluene, which is chlorinated and form benzyl chloride. On hydrolysis, it gives benzaldehyde. Now the very important reaction by Gattermann-Koch reaction, when benzene or its derivative is treated with carbon monoxide and hydrogen chloride in presence of anhydrous aluminum chloride or cuprous chloride, it gives benzaldehyde or substituted benzaldehyde. Here is the reaction. Benzene is converted into benzaldehyde by carbon monoxide, HCl, and anhydrous aluminum chloride or cupryl chloride. Now the physical properties of aldehyde. First is a methanol is a gas at room temperature while ethanol is a volatile liquid, or other aldehydes are solid or liquid at room temperature. Second is the boiling points of aldehyde is higher than hydrocarbon and ethers of comparable molecular masses. Third is their boiling point are lower than alcohols. The lower members of aldehyde like methanol, ethanol are miscible with water in all proportion because they form hydrogen bond with water. Now the solubility of aldehyde decreases rapidly on increasing length of alkyl chain. All aldehydes are fairly soluble in organic solvent like benzene, ether, methanol, chloroform, etc. Lower aldehydes are sharp pungent orders. As the size of molecule increases, the order becomes less pungent and more fragrant. Example butyraldehyde. Okay, the chemical reactions of aldehyde. First is the nucleophilic addition reaction. This is the reaction. We go step by step. The first step is carbonyl is attacked by a nucleophile. In this reaction, the nucleophile establishes a connection with an electrophilic C double bond O carbon atom, which results in a rehybridization of carbonyl carbon from the sp2 position to the sp3 position. The electronegative oxygen atom is drawn to the electron in the pi bond, resulting in tetrahedral alkoxide intermediate. Second step is there is a no leaving group, thus addition occurs. The addition of acid causes the alkoxide to be protonated, then resulting in the formation of alcohol. In the presence of strong nucleophiles such as RMX like Grignard reagent, RLI and RCCM, the C double bond O bond is directly attacked, forming the intermediate. On the other hand, weak nucleophiles such as water, ROH and RNH2 necessitate the use of acid catalyst. Here is another reaction, addition of sodium hydrogen sulfide. See, we can see here is a acetaldehyde reacting with sodium hydrogen sulfide gives us addition product. Third method is addition of Grignard reagent. Reacting a Grignard reagent with aldehyde gives us secondary alcohol. As you can see here, R is attacked to carbonyl group and then formation of secondary alcohol by hydrolysis. Another reaction is addition of alcohols. Aldehydes react with one equivalent of monohydric alcohol in the presence of dihydrogen chloride to L-alkoxy alcohol intermediate known as hemiacetals, which further react with one or more molecule of alcohol to give a gem dialkoxy compound known as acetal as shown in this reaction. Now here is another reaction, addition of ammonia and its derivative. Ammonia adds readily to many aldehydes to form ammonia adducts. However, these aldehyde ammonia adducts usually are not stable. They radially undergo dehydration and polymerization. Let's see reduction. First is a reduction to alcohols. Aldehyde is reduced to primary alcohol by sodium borohydride or lithium aluminum hydride as well as catalytic hydrogenation. Sodium borohydride and lithium aluminum hydride is reducing agent. So here is a reaction. Okay, here is another reduction to hydrocarbons. The carbonyl group of aldehyde is reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid. It is also known as Clemmensen reduction, or with hydrazine followed by heating with sodium or potassium hydroxide in high boiling solvents such as ethylene glycol, also known as Wolff-Krishna reduction. Here is really important name reaction. Pause or take screenshot. Okay, here is another reaction, oxidation. Aldehydes are easily oxidized to carboxylic acid on treatment with common oxidizing agent like nitric acid, potassium permanganate, potassium dichromate, etc. Even mild oxidizing agents, mainly Tollens reagent and Fehling reagent, also oxidize aldehyde. There is a simple reaction of oxidation to aldehyde to carboxylic acid. Now the Tollens test and Fehling test. These two tests are very important in practical knowledge also. Here is a Tollens test on warming an aldehyde with freshly prepared ammoniacal silver nitrate solution. It is also known as Tollens reagent. A bright silver mirror is produced due to formation of silver metal. The aldehydes are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. Here is the reaction. Now Fehling's test. Fehling reagent comprised of two solutions, Fehling solution A and Fehling solution B. Fehling solution A is aqueous copper sulfate and Fehling solution B is alkaline sodium potassium tartarate, means Rochelle salt. These two solutions are mixed in equal amounts before test. On heating an aldehyde with Fehling's reagent, a reddish brown precipitate is obtained. Aldehydes are oxidized to corresponding carboxylate anion. Aromatic aldehydes do not respond to this test. Here is the reaction and gives us red-brown PPT. Now the reaction due to alpha hydrogen. The aldehyde undergoes number of reaction due to acidic nature of alpha hydrogen. Here is a basic mechanism of acidity of alpha hydrogen in presence of base. Okay. Now aldol condensation. Aldehyde having at least one alpha hydrogen undergo a reaction in presence of dilute alkali as catalyst to form beta hydroxyaldehyde, also known as aldol. This is known as aldol reaction. Okay, here is the reaction. Ethanol is converted into but to enol. Now cross-aldol condensation. When aldol condensation is carried out between two different aldehydes or ketones, it is cross-aldol condensation. If both of them contain alpha hydrogen atom, it gives mixture of four products. This is illustrated below by aldol reaction of a mixture of ethanol and propanol. Here are the four products. Now the last other reaction like Cannizzaro reaction. Cannizzaro reaction is aldehyde which do not have an alpha hydrogen atom undergo self-oxidation and reduction reaction on heating with concentrated alkali. In this reaction, one molecule of aldehyde is reduced to alcohol while another is oxidized to carboxylic acid salt. Here is the reaction with formaldehyde and with benzaldehyde. Now the electrophilic substitution reaction. Aromatic aldehydes and ketones undergo electrophilic substitution at ring in which the carbonyl group acts as deactivating or meta-directing group. Here is a nitration and benzaldehyde gives M-nitrobenzaldehyde. Now the uses of aldehydes. First is in chemical industry, aldehyde is used as solvent, starting material and reagent for the synthesis of other products. Second, formaldehyde is well known as formalin solution used to preserve biological specimens as you see in your zoo lab and to prepare bakelite glues. Third one is acetaldehyde is used as starting material to prepare acetic acid, ethyl acetate, vinyl acetate, polymers and drugs. Fourth is benzaldehyde is used in perfumery in dye industry. The last but the not least, many aldehydes are well known for their odors and flavors. Okay, thank you friends to watching this video. If you found it useful, like, share and subscribe to my YouTube channel.